Hi, my name is Andrew and I'm doing derivatives and rate of change. So the derivative is the rate of change at a certain point, and rate of change is the change in y over the change in x, which is the slope. M equals change in y over change in x. And then the tangent line of a graph is the slope at a certain point. So the actual equation to find the derivative is the limit has h goes to 0 of f of x plus h minus f of x divided by h. So here in example 1, we have the equation f of x equals x squared. We have a table representing the points and a graph representing the points. So first of all, we plug into the equation f of x plus h minus f of x. And f of x plus h is x plus h times x plus h. And f of x is x squared. And then we have to divide this all by h. So we multiply out and we get x squared plus 2hx plus h squared minus x squared, all divided by h. You cancel out the x squared and you get 2hx plus h squared. Then you cancel out the h and you get 2x plus h. Then you plug in h for 0 and you get 2x. Now here are some notations for the derivative. It is f prime of x, y prime, dy over dx, d over dx times f of x, and then capital D subscript x times y. So for in example number 2, we have if f of x equals 4x squared plus 10x, find the equation of the tangent line at x equals 2. So first of all, we find f of x plus h, which is 4x plus h times x plus h plus 10x plus h. Then we minus it by f of x, which is negative 4x squared minus 10x, and this is all divided by h. So we multiply out the x plus h, and then we get 4x squared plus 8hx plus 4h squared plus 10x plus 10h minus 4x squared minus 10x, all divided by h. Then we cancel out the x squared and the x's, and we get 8hx plus 4h squared minus 10h divided by h. Then we cancel out the h's and we get 8x plus 4h minus 10. Then we plug in 0 for h and we get 8x minus 10. So then, because we want to find the tangent line at x equals 2, we plug in 2 into the derivative, which is 8 times 2 plus 10, which is equal to 26, and f of 2 to find the y value at x equals 2, which is 4 times 4 plus 10 times 2 is equal to 36. And then we're able to make the equation of the tangent line, which is y minus 36 equals 26x minus 2. Now this could be used in real world scenarios like finding the rates and velocity, acceleration, and population growth, and production rates. So now we'll be going to a real world scenario. So now we have Mr. Hap has a lifeguard, and he sees something. He sees a puppy drowning in the middle of the ocean. So Mr. Hap goes into the water and swims towards the puppy. Now here's our problem. If the puppy is going to drown in 60 seconds and the puppy is 100 meters away from Mr. Hap, what is the average velocity Mr. Hap has to go to save the puppy? So first of all, we plug in. So first of all, we just find the change in y over the change in x, which is 100 divided by 60, and we get m is equal to 5/3 meters per second. Now we're going to go into our next real world scenario. So now we have a cliff, and then we have Stanton riding on a skateboard holding cotton candy on a cliff. And now he's going off the edge. So now we have to find how fast Stanton is at 2 seconds. The cliff is 122.5 meters, and our equation is d equals negative 4.9 x squared. And d is the distance, and x is equal to time. So here is what you do. So you get your original equation, f of x plus h minus f of x. Then you plug in x plus h into the original equation, and then you get negative 4.9 times x plus h times x plus h, and then you minus it by f of x, which is 4.9x squared. And then you cancel out the 4.9x squared, and then you cancel out the h's, and you're left with negative 9.8x minus 4.9h. And then you plug in h for 0, and you get negative 9.8x. Then you're able to plug in 2 into the equation because x equals 2. And then you can find out that Stanton is moving negative 19.6 meters per second while he's falling down the cliff at 2 seconds. So now, moving on to the next equation, we have to find how fast Stanton is going at the moment he hits the water. So, all we need to find is what the time is when he hits the water. And in order to do that, we use distance, which is 122.5 meters, and we set it to negative because he's falling down. And then we plug that into d equals negative 4.9x squared, and we get negative 122.5 equals negative 4.9x squared. Then we divide 122.5 divided by 4.9, then we square root both sides and you get 5 seconds. Now, using the previous derivative, we could use negative 9.8x, and then we could plug in 5 seconds into that to find the speed at 5 seconds, which is negative 49 meters per second. Here are some misconceptions and helpful tips. A misconception could be that the derivative is just a linear equation, but if you have something like x to the fourth, the derivative of that would not be linear, would be 4x cubed. A helpful tip when finding the derivative is to know Pascal's triangle to solve long exponential polynomials. The end.